So proceed to our next chapter, which is processing array content. Array element can be treated as an ordinary variable of the same type as the array, which means the element inside the array is actually same with the x and y and z that we usually use in C++. And then when using a plus plus and minus minus operator, don't confuse the element with subscript, but make it like this. So it means to add 1 to the test I, but don't make it like this. Yeah. So if you guys put like this, the increment I, which means no effect on the test array, which means it's not gonna add 1 to the test array. So we proceed to our next topic, which is array assignment. To copy one array to another, don't try to assign one array to the other. For example, like this, it won't work. But instead, assign element by element using a for loop. For example, like this.
Next, printing the contents of an array. You can display the contents of a character array by sending its name to cout. For example, character name factory, you can just cout the character array. But this only works with character array. For other types of arrays, you must print element by element. The example is shown by below.
Summing and averaging array elements. Use a simple loop to add together array elements. In tnum, double average sum equals to 0, for tnum equals to 0, tnum less than size, tnum plus plus. Sum plus equals to test tnum. One sum can compute average. Average equals to sum slash size.
So, for this program, we're going to find the highest value using array. Firstly, the important part is the include IO string using namespace std and int main and the braces, and then the statement. So, in this statement, we are going to do the array to find the highest value. And as you can see, I have defined and initialized the array. So the name of the array is values and the data type is double, and we have 5 elements because we have 5 values. We know that the program have 5 values because in the square bracket it stated 5. So that's why we know that we have 5 values, 5 elements, which is the elements is 3, 1, 7, 9, and 0. So I have defined the highest as variable and I have stored values to 0, which is the element for values 0 is 3. So basically for this part, the program gonna check which element is the biggest value. I have initialized the I equal to 1, so we're gonna check values square bracket 1 equal to element 1, which we can see at the double values square bracket 5 equal to 31790. We can see that. And then we're going to check if the element is bigger than the previous one. So if the values 1 is bigger than the previous one, so it's going to be the new highest value. Then we're going to look at the next element. So if the element is bigger than element 1, then it's going to be the new highest value, and so on. So after they have finished the looping and they find the highest value, they're going to print or cout the highest value to the monitor. So the highest value for this program is 9. This is a program to find the lowest value in an array. It works the same as how we find the highest values as the previous program. So the lowest value for this program is 0.
Partially filled arrays are used when it is difficult to know the exact array size needed, and when sometimes we add and remove elements to array as we progress with our algorithm. We might not even know ahead of time how many elements we will wind up with until we reach the end of the program. To work with a partially filled array, we generally need to have an access to the array itself. An integer counter indicating how many elements are currently in the array, the size or length of the list, an integer counter indicating the maximum number of elements that we can have without overflowing the array, the capacity of the list. Firstly, we have to make the array large enough to hold the large expected number of elements, and secondly, use a counter variable to keep track of the number of items stored in the array. The example shows how we specify the size of the array to be large enough in order to reserve the extra space for the future element. Comparing arrays. Two arrays are said to be equal if both of them contain the same set of elements. The permutations of the element may be different though. If there are repetitions, the count of repeated elements must also be the same for two arrays to be equal. Sorting the arrays. To check if two arrays are equal or not, we have to compare the exact occurrence of each element in both of the arrays to be the same. However, the problem is that the values of the arrays could be in any permutation irrespective of each other. If we could order them in any way, then it would be easy for us to check their number of occurrence. So, we will sort both of the arrays and linearly transverse on it while comparing each element of the arrays. If at any indices after sorting them they mismatch, then we could return false from there, otherwise we will return true. Solution steps. First, compare the lengths of array 1 and array 2. If they are equal, then we will continue, otherwise return false. Second, sort array 1 and array 2 either in ascending or descending order. Third, for each index of the array, compare array 1 and array 2 to be equal. Fourth, if any point of the condition fails, then return false, otherwise, at the end of the comparison, return true. This is an example on how to compare two arrays.